All right, so we're going to do lesson 1.3 using midpoint and distance formulas. Midpoint and distance formulas should be somewhat familiar to you because it is something that you do cover in Algebra 1. Now, I'm going to try to do this as fast as I can. However, there's a lot of information in this section, so I might go slightly over that 10 minutes. But again, I'm going to try and keep it as close to 10 minutes as possible. Now, for midpoint and distance, the midpoint of a segment is the point that divides the segment into two congruent segments. Now, you do have some vocab over off to the side there. So for this section, you only have these three vocab words. Now, hopefully you already defined those. If you haven't, again, make sure you have your flashcards ready. You can define them as we go. But again, midpoint, the midpoint of a segment is the point that divides the segment into two congruent parts. So on this diagram, you have endpoint A, you have endpoint B, and then M, that's the midpoint of this segment. So M is the midpoint of segment AB. So that segment AM is congruent to segment MB, and the length of AM is equal to the length of MB. All right. Now, a midpoint is a type of bisector. So a segment bisector is a point, ray, line segment, or plane that intersects a segment at its midpoint. A midpoint or a segment bisector bisects a segment. So again, a midpoint is a type of bisector. Down there on the other diagram, they're showing a line CD, intersecting with the midpoint. So segment or line CD is a segment bisector for line segment AB. All right. Let's go ahead and go to the next slide. All right, example 1. Find segment lengths. So on here, it shows that we have a skateboard. In the skateboard diagram, it says that XT, so XT, that's that entire length of the skateboard, is 39.9 centimeters. Oh, actually, sorry, that's half the length of the skateboard, half the length of the skateboard, 39.9. Identify the segment bisector of XY, segment XY, and then find the length of XY. So on here, VT is bisecting the segment. All right, so since VT is bisecting this segment, those two pieces are going to be congruent to each other. So they are marked already on the skateboard as being congruent. So we know both those pieces are going to be equal to the length of 39.9. Now, we can write an equation to find the length of the overall deck of the skateboard. So the deck of the skateboard is represented as the length of XY, and then we're going to add those two lengths together. So again, it's just the 39.9 twice. So we're really just adding it. So the length of the skateboard is going to be 79.8 centimeters. Now, we are going to have to use some algebra. All right, I said that we were going to use algebra this year. In the examples we did with 1.2, we have not done any with algebra yet. But in Tuesday in class, you will see a couple examples using segment addition where you will have to use some algebra as well. This one is a midpoint problem using some algebra. So we know that ray, MN, is a segment bisector of segment VW. We need to find the length of VM. So they gave us the length of both VM and VM and MW as algebraic expressions. So first thing that we need to do is take those expressions and write an equation. So we know that VM is equal to MW. So that's the lengths of those. Substitute in those two expressions. So we have 4x minus 1 is equal to 3x plus 3. So now we have an equation. We know that they're equal, so we could set them equal. We need to solve it. We need to get all of our variables to one side, all of our constants to the other. So we take that 3x, we subtract it from both sides. We end up with 1x minus 1 equals 3. We bring the 1 over by doing addition. So add 1, you get 4. So we have x equals 4. Once you know what x is, on this problem, we need to plug it back in. We're trying to find the length of VM. So plug the 4 back into the expression for VM. So we have 4x minus 1. So now it's 4 times 4 minus 1. 4 times 4 is 16. Minus 1 is 15. If we want to double check this, We could then take that same value and plug it into MW. So MW is 3x plus 3. If we plug 4 into that side of the equation, we should also get 15. So 3 times 4 plus 3 is 15. So again, we checked our work. All right. Now we will be doing a construction. The construction for this one will be a lot different than the construction we did today. We're actually going to use something called patty paper on Monday. So construct a segment bisector of segment AB by folding paper. All right. And we're going to label the midpoint M for AB. So these are the steps. And again, we'll do this on Monday. We're going to first draw a segment onto our patty paper. We're going to take that patty paper and we're going to fold it in half. Well, not exactly half. Fold it so that they line up. So A and B will be right on top of each other. You'll be able to see through it. And once you do that, there'll be a crease in the patty paper. That crease is going to pass through our line at its midpoint. So when we find that midpoint, you can label it M. And again, that's one way to do a construction using patty paper. So we'll take a look at that on Monday. All right. Weighted average. This is the one part of this entire lesson that's not from algebra. Everything else in this is from algebra. So when we do a weighted average, when two distinct points A and B are weighted equally, the average is the midpoint of A and B. When points are weighted unequally, the average is the weighted average. So here they're showing an example of just having one point at each location or having multiple points at different locations. Now, how do you do a weighted average? So we know that in order to do an average, it's the sum of our values divided by the total. Well, on this one, it's the sum of our weighted values divided by the sum of our weights. So it's still sum of the values over the total number of values we're using. It's just slightly different since we have, again, more of one number than the other. So we'll take a look at how to do this. Find each weighted average. So on this one, you have a number line, you have 1 point at 2, you have 2 points at 8. So the coordinate 1 has a weight of 1, the coordinate 8 has a weight of 2. So now we're going to take and multiply the number of times you have a point at that value and add the sums together. So the sum of the weighted values. So we have a 2, we have an 8. The 2 only appears once, so we're going to multiply 2 by 1. The 8 appears twice, so we're going to multiply the 8 by 2. Then on the bottom, we have 1 at 2. We have 2 8s. So now we can multiply and add these values together. 1 times 2 is 2. 2 times 8 is 16. Add those together. That's 18. You have 1 plus 2 is 3. And 18 divided by 3 is 6. So they kind of left out some steps there. But we have this top part first, we would have said is 18. And the bottom would have been 3. So 18 divided by 3, which is 6. We get the same thing if we did a regular average just by taking the 2, adding it. So 2, and then 8 and 8. So thinking of it as 3 different numbers, 2, 8, and 8. If we added those values up and then divided by however many there are. So it's still the same idea. Find each weighted average. So again, on this one, we have more dots, same idea though. So let me fast forward to our equation and walk us through this. So on the top, we have 1 at 3. So we have 1 times 3. We have 3 at 5. So we have 3 times 5. We have 2 at 9. So we have 2 times 9. How many dots are there total? Well, there's 1 here, there's 3 here, and there's 2 here for a total of 6. So we're going to add up. We're going to multiply on the top and add them together. On the bottom, we're going to add them all up and then divide. And the weighted average is 6. Now, midpoint formula, again, should be familiar to you. So if you don't remember this from algebra, again, it's an equation that you should know. Essentially, what you do is you're taking the average of the x values and the average of the y's. So it looks more complicated than it is. But it's showing that you're taking your x values from your 2 endpoints, adding them up, and dividing by 2. So that's an average of the x's. Then you're taking the y values from your endpoints, adding them up, dividing by 2. So that's an average of your y values. So using the midpoint formula, the endpoints of RS are at 1, -3, and 4, 2. So there's a graph to show us what it looks like. Now, it doesn't matter which one you call x1 and y1 and which one you call x2 and y2. So first, assign your values. So we're going to use the midpoint formula, which again requires us to use the x1, y1 and the x2, y2. We're going to call one of them, in this case, r, x1, y1, and s, x2, y2, and then plug those values in. So once we plug in the x values, we had a 1, we had a 4, we plug those in. For the y values, you have a 2, you have a -3, we plug those in. We add them up and divide by 2 in each case. So 1 plus 4 gives us 5, and we have 5 over 2. On the other one, -3 plus 2 is 1, so -1 over 2. So our new coordinate for our midpoint is going to be at 5, 2, and -1 over 2. And if you want to change that to a decimal, you could. That'd be at 2.5 and -0.5. All right. The next one. So same thing. So now we're talking about midpoint for JK. So you have that line. We're going to find the midpoint by plugging those values into our midpoint formula. So the first step, find x. So again, average the x values, then average the y values. Again, this is just showing the same work. It's just splitting it up into two separate parts. So whether you write it out as the midpoint and you put it both in the parentheses and then simplify it, or if you do it as two separate steps, doing the x values first as an average, doing the y values second as an average, again, it comes out to the same answers. So on this one, we had the 0.3, -2. Distance, again, this is also from algebra. So our distance formula should look familiar. Now, the distance formula, the way it's written there, is a little bit different than we're used to. So I'm going to write here at the top, the square root of, or actually I should say d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. That is our formula that we're using to find distance. Now, distance formula is actually another formula. It's based off of something called Pythagorean theorem. You may have talked about Pythagorean theorem in algebra. You may have also talked about it in 6th grade as well. But Pythagorean theorem, the idea is c squared equals a squared plus b squared. It's based on a right triangle. So down here we have a right triangle drawn where we have our two sides, a and b are our two legs. C is the hypotenuse of that triangle. Now, in order to find C, we take the length of A and the length of B and plug them in to that equation. So a squared plus b squared. And then the length of C squared as well. Well, in our distance formula, it's the same thing. Notice they drew the triangle on this one. They have our coordinate points. They have our x1, y1. They have our x2, y2. And now they also identified that this third value over here in the corner would have been a combination of x2 and y1. So if I'm finding the distance across this side, which on the first one is labeled as A, I'm doing x2 minus x1. That'll give me that distance. Over here, y2 minus y1 will give me that distance, which in the other figure is labeled as B. So this piece, the x is really our A squared. This piece is really the same as our b squared. Now, the other side is our c value squared, and that's the length of AB. So they have our formula, they plug it in, and then they rewrite it so that distance, we actually have, again, the d out in front. So if you look back up here at the top, the d doesn't have the squared. That's why in this original equation here, we have the square on AB. If you get rid of that square by square rooting it, then it goes to the other side, and we have our distance formula that we have up here at the top. Right. That's where our distance formula comes from. It comes from Pythagorean theorem, which we will use Pythagorean theorem a lot more during the school year. All right, so here's our distance formula written with our square root. Again, it's something that you should be familiar with, but now we're going to take some values and actually plug into that distance formula. The title of this is actually wrong. This is finding distance. Finding distance. All right. So on here, we have our points given to us for our different locations. We can plot them on a coordinate plane and then find the distance between those 2 points by using that distance formula. So we'll assign our x1, y1 value and our x2, y2 values for those 2 spots. If you had switched it, it'd still give you the same outcome in the end. So we're going to plug them in. So substitute in, we have the 4, we have the 2 for our 2 x values. We have the 3 and the -1 for our 2 y values. And then we're simplifying. Now, if we wanted to draw that triangle instead, so let's say we turn this into a right triangle for a second. This distance is 2, this distance is 4. Notice at this point, I have my a squared and my b squared. So we're going to keep solving. We have 2 squared was 4. 4 squared was 16. They both came out to a positive value because if negative squared is a positive. 4 plus 16 is 20. And the square root of 20, now that's going to take a calculator to simplify down to a decimal. We will talk about simplifying radicals later in the year as well. But on this one, it's 4.5 or roughly 4.5. This little double squiggle means approximate. So again, we're going to use that approximate symbol a lot this year. So it's approximately 4.5 miles. All right, that's it. So now this is our reference sheet. You'll notice that on this reference sheet, we have our distance formula and our midpoint formula already given to us. So again, it's not going to be something that you have to actually have completely memorized. Should you know it? Yes. Are there going to be other tests that would be a lot helpful for you to know it? Yes. Again, this time around, it is on a reference sheet. You'll have it for every test and every quiz. Now, other things that you need to make sure you do, finish the vocab. So you have the vocab list. I updated it. It's on Canvas. So look at that list. You need to have 1.3 done before Monday, but that's it. All right. Hopefully I can answer any questions in the classroom on Monday. I know I went a little bit longer than the time I wanted to. It was more like 15 minutes. Again, watch it on double speed. It won't take that much time. Have a good day and a good weekend.